Welcome to Software Supply Chain 101, Understanding Dependencies. If you know what software dependencies are, otherwise known as software packages, modules, components, a million other ways to reference them, but I'll be calling them mostly dependencies and packages throughout the talk. It'll probably be somewhere along the lines of like 20, 30 minutes presentation, depending on questions that might pop up throughout. And please do feel free to interrupt and ask any questions that you may have. And then probably another like 15, 20 minutes of me just ranting and complaining about all the work that I do and the industry that is pretty much my entire life at this point. As far as background on myself, my name is obviously Kyle Kelly. Well, not obviously, since we're on Discord. I often go by circles in the Discord world, but I'm a security researcher at Semgrep, which is a very fast open source static code analysis tool. But we've also built a enterprise or commercialized platform, including static code analysis, software composition analysis for supply chain security, and then also now our latest product, which is secrets detection. Additionally, I'm the founder at CramHacks, which is a weekly software supply chain security newsletter, and I also post relevant blogs. And then lastly, which I actually don't have on here because I haven't updated this slide, but my primary income comes from managing a cybersecurity consulting firm called BankSec, where we provide financial institutions across the United States cybersecurity consulting services, IT general controls, IT audit, incident response, things like that. But don't think of it as like your Bank of America's or Chase. We're talking more community banks and credit unions, anywhere from like 100 million in total assets under management up to around 200 billion, which 200 billion is actually still not a top 20 bank. Our average client is around 4 billion, to put it into perspective. I do have a master's degree in computer science, which I just finished this December. Very happy to be done with school, probably forever. I am maybe not smartly considering a PhD, but it's something that I would love to be able to do if I could just stop caring about money. But I do like money, especially living in San Diego when you have a mortgage, which is a new thing for me as well. I miss living. I quite literally lived in my grandma's basement until about a year and a half ago. So I'm still learning how to be an adult. And then because I work in the consulting space, need as many letters after my name as possible. So within my first year, or within my first 2 years, I'd say working at the consultancy, I picked up the CISSP, OSCP, GWAPT, GCI, GSEC Plus, and there's probably a couple others that I just haven't renewed or completely forgotten about. I think I had some AWS certifications, stuff like that. But as of late, really just deep diving in on the software supply chain security space. It's definitely evolving. There's been, for example, executive orders and White House coming from the White House, as well as EU and potential US legislation strictly focused on software supply chain security. Things like SBOMs, if you've heard of them, software bill of materials. It's really causing a stir in this space. And I will get into rants, but to TLDR, it's a freaking nightmare. LinkedIn's probably the best way to contact me if you ever want to reach out directly. So I put my link there, but you could probably find me just by searching for Kyle Kelly. All right, long introduction. But as far as an agenda, I'll be going over what is a software dependency, especially for those of you who are less familiar. I will, or maybe don't have software development experience, things of that nature. I'll talk about a lot of the mistakes that I made in my earlier days, which weren't that long ago. Talk about dependency management, the importance of build reproducibility, virtual environments, which honestly, you'd be amazed how few people are actually implementing these, including some pretty prominent technology companies. And then we'll talk about supply chain vulnerabilities specifically, some generic trends, what reachability is, which is our kind of our flagship feature as far at Semgrep when it comes to supply chain security. and then I'll walk through Semgrep just from a higher level perspective and how you can use open source Semgrep for vulnerability research, or you can even use our full platform for any open source projects because it's entirely free.
Okay. Sorry, we got a hot mic.
So yeah, just want to throw out this quick disclaimer, basically saying a lot of this is very ecosystem specific. So you know, something for JavaScript isn't necessarily identical for Python versus Java versus Rust or whatever it has, whatever has you. So I'll primarily be talking about JavaScript or Python just because that's what I most commonly work with. But I could try to answer questions outside of those ecosystems. I just can't guarantee I'll have the answers. So yeah, what is a software dependency? Well, the way I like to put this into perspective is, say you want to write a letter. Now, what are things that you need to write a letter? You probably need a pen and paper. Now, you can go out to your backyard and chop down a tree and form the paper, and I don't know how the hell you're gonna make a pen, but you might you might be able to. Um, Odds are you're just gonna go to the store and you're gonna pick up a pen and paper. So same thing in the software development space. A software dependency is saying, hey, somebody has has written this code before me. I'm just going to import their code and directly reference either a class or function that they've already written so that I don't have to write it from scratch. So if you've ever done something like in Python, you might do import requests at the top of your file. That's ultimately going to be importing the request package, which is an open source project, and enables you to make references to the request package code. And then where things get a little tricky is transitive dependencies, which I often refer to as third, fourth, or fifth party dependencies. So when you import that request package, the request project will also have dependencies. At least that's the very high degree of likelihood. And then those dependencies will also have dependencies. So it creates a very large chain of open source projects or packages that rely on one another. And that's where things get very hairy because if you have a vulnerability in one of those, well, how far down the chain does that vulnerability impact? And how can you even discover these vulnerabilities in the first place? Because odds are, you're not subscribed to these projects and they're not blasting it all over the world saying, hey, there's a new vulnerability, like make sure you update or whatever has you. Some projects actually do that. I really respect those guys, but for the most part, it's not happening. So just to give you an example of the magnitude of these, on GitHub, you can actually go to the insights page and view the dependency graph and then the dependents. And the total number of dependents are known GitHub projects that have that package in their lock file or manifest file, which I'll touch on what those are exactly. But the request package itself is used by almost 2.5 million repositories. So this one project, if it were to have a vulnerability, could possibly be impacting over 2.5 or just under 2.5 million open source repositories. That's excluding internal and enterprise or local projects. And then it's also including 85,000 other packages. So those would be, if there was a request vulnerability and somebody was using one of these 85,000 packages, the request vulnerability would be a transitive vulnerability because it's a request is a dependency used by these packages. And so the way I usually summarize it, I went, I don't know how many years using pip install or poetry install, npm install. I had no idea what the heck I was doing. I just knew that I read on Stack Overflow, I need to write this out in order to use this function. So I just did it. Funnily enough, I understood it a heck of a lot better in like C and C++ when you're actually locally storing these libraries and then directly calling them. But I mean, pip I always thought was just friggin' magic, to be honest. So yeah, if you use any of these, you've definitely used a software dependency or package in the past. And so just some quick fun facts about dependencies. PyPy, which is whenever you're doing a pip install, you're likely pulling a software package from PyPy, which is a public package repository. It currently hosts just about 500,000 total packages. But when you account for all the different versions for these packages, there's actually over 5 million releases, which is pretty crazy. And this is specifically just open source. That being said, if you look at NPM, which is the largest public package repository and supports primarily JavaScript and TypeScript, there's, I believe, just over 3 million total packages. And I don't recall the number off the top of my head as far as releases, but I think it's well over 10 million. And if you're wondering, how many people are actually using open source software packages, well, roughly 98% of all applications use open source software, and over 90% of organizations use open source software. Honestly, that 90% figure to me, I think is kind of BS. I don't. I have dealt with one or two orgs that have told me they do not allow open source code, but I have no idea how they get anything done. And frankly, when you go to their website or application, it's kind of apparent that they maybe don't use open source software. Um, Sorry if you're one of those, but that's just been my experience. That being said, speaking on direct versus transitive dependencies, there was a 2020 GitHub Octoverse report, which resulted that for JavaScript projects with only 10 direct dependencies, so if you do npm install 10 times, on average, your project is likely to utilize 683 total dependencies. So you're using 10 packages, but those 10 packages are bringing in an additional 673 dependencies. Sometimes you might do like pip install a package name, and it might take like 30 seconds to load, even though you're installing a very tiny package. And that's because of all the transitives. That's a likely cause of it. There was also just a quirky NPM report, like quirky stats in NPM, published by Socket. I believe it's socket.dev, socket.io. And they're a supply chain security startup, but they were talking about the largest NPM package, which I think was like 5.5 gigs or something like that. It's crazy. There was also just recently a package published that listed every single NPM project or package as a transitive dependency. So when you tried to install it, I think it was called everything. When you tried to do install everything, it basically just like dust your terminal. Like it would just explode. But it became interesting because apparently if a package uses another package, you can't delete it. And so there was the way that they had it structured, they were using all of their own packages for the everything project, which meant that they couldn't delete the everything project from npm, and it was like it was a whole mess. Basically nobody could delete their projects from npm for a couple of days. And so why does this dependency management matter? And a lot of it has to do with this term dependency hell. It's just when you are not properly managing what software dependencies you're installing in your environment, you run into dependency hell, where there's just, you might need a dependency, but maybe you previously installed a different version. And so now your terminal isn't saying, hey, you don't have the right dependency, it's just crashing. Because the project you're trying to run is expecting a specific version of the dependency, but it doesn't know that you have an incompatible version, things like that. And that's why build reproducibility is super important. But I have this nice meme here just to go over manually installing software dependencies. Basically, just don't do it at all. Like if don't do pip install, you're going to want to use a virtual environment, but ultimately you need to be using a package manager to handle dependencies. And so build reproducibility, the easiest way to put this into context is maybe you go to GitHub. If you're a script kiddie like me, you go to GitHub, you take a proof of concept and you download it and you try to run it, and it just doesn't work. So that the next step would be to say, hey, is there a requirements.txt file? Okay, yes, there is. Let me do pip-r requirements.txt to install the dependencies for this project. Okay, so I did that. I try to run the POC again. It still fails. That means build reproducibility sucks. Basically, build reproducibility means that anybody should be able to download your project and through simple instructions, be able to make it run as expected or as intended, which avoids the whole "it works on my machine" syndrome. And what has really become tremendously helpful for this are virtual environments, and especially Docker. Docker is fantastic. Just if you're not really familiar with Docker, the way that I usually explain it is, imagine instead of trying to write code that's compatible for people, you just hand them your computer. You just like clone a copy of your terminal, which has all of your packages already installed, and you say, here you go. It should just work. Um, it doesn't always happen that way, but it often can if done properly. I put please, pretty please care about this because people really seem to not, and it becomes nightmarish because a lot of the software supply chain security tooling released these days kind of expects this to be a, a best practice. They expect people to be doing this. And so something like software composition analysis, which ultimately is just identifying what dependencies your projects are using, uh, it, it's very difficult, somewhat impossible, if you're not managing what using something like a requirements.txt, virtual environments, or Docker. And so if you are familiar with pip, which I'm sure many of you are, and you're doing pip install, I would very much encourage you to stop doing that unless you're using like venv or virtual env in addition to in addition to pip. But there is this thing called pipenv, which basically combines virtual environments and pip. So one thing that I used to run into all the time is that I would pip install a lot of dependencies, and my my environment would just turn to mush. Like I just had so many different dependencies installed, different versions, and it became such a big headache. Whereas pipenv creates a virtual environment for the particular project or particular directory. So say I clone something from GitHub, I can create a fresh instance. Just say like, start from scratch. This is my brand new virtual environment. Let me install whatever I need to, and I can run it in this directory. Now, when I go to clone the next project, I'm going to create a new virtual environment. Nothing's ever actually getting installed on my local machine. So like if I were to list all the packages I've installed with pip on my local machine, hopefully there would be pretty much nothing. But if I go to a particular directory for a project, I would see all the dependencies that are necessary. This has been a lifesaver. Poetry is a good alternative. This specifically for Python. Um, Other languages do have similar solutions. And this was my classic example where I really can't explain how often I would just like uninstall pip and Python and delete everything and start from scratch because it became so messy. And then I felt like an absolute idiot when I learned about virtual environments. But it's okay. We all start somewhere. Oh, actually, this is what I used to do. This was my favorite, where you clone a project and you try to run it, and it says no module named, and then you pip install that specific project or package, and then you try to run the script again, and it says no module named, and then a new one, and you just keep repeating it until the project runs. Oh god, I don't know how I did anything back then. So I do have a quick demo. It's a little small, but hopefully you guys can see. Hopefully the quality. Okay. So yeah, and this basically I'm just cloning a damn vulnerable. This is actually a damn vulnerable Python web application. So if you're familiar with just the standard damn vulnerable web application, this is a Python version. So I cloned that project, and you can see there was a requirements.txt file. So I printed that out, and this a requirements.txt file is also commonly referred to as a manifest file. So it's going to list out all direct dependencies. Now this requirements.txt is a bit outdated, so it actually includes some transitive dependencies where you see the comment and the via AIO HTTP, for example. So those are transitive dependencies that are listed in the requirements.txt. Nowadays, that's not really necessary. It's actually not recommended either. Looks like I started over. So what's better than well, I guess if you ever do get a project that doesn't have a requirements.txt file, it's helpful to know that you can actually generate one using pip requirements or pip recs. So what this does, it actually looks at your code and it says what import statements are there, and then it can actually predict with pretty good accuracy what dependencies are required. So this generated a new requirements.txt file for me, but it didn't include the transitives because, like I said, that's not really a standard practice these days. So now I'm going to show using pipenv to create a virtual environment, and then I'm going to install all the dependencies from the requirements.txt file. So created the virtual environment for this directory, and now it's going ahead and installing the dependencies, and then it's going to lock the dependencies, meaning it's going to lock what version and also provide a hash for assurance and things like that. But before we get into that, now we have a requirements.txt file, but we also have a pip file, which is a more matured manifest file, I would say, where it very clearly specifies what Python version is required, what dependencies, what direct dependencies, and what versions are required. The manifest file doesn't always have to specify the exact version. You can use Semver specifications to say like, hey, I want to install the latest version, but you can use an asterisk for that. So where it says AIO HTTP equals, rather than saying 3.8.6, it could be an asterisk. And now every time somebody tries to reproduce this project, it's going to just take the latest version of this dependency. You can also only allow patch upgrades or minor upgrades. A patch upgrade would be 3.8.7, for example, instead of 0.6. And then a minor upgrade would be like 3.9.6. So there's actually a specification that says for patch upgrades, it should not be a breaking change. Similarly, for minor upgrades, it should not be so a patch upgrade should pretty much never be a breaking change. Minor upgrade might be, but pretty rare. And then a major upgrade will pretty commonly have breaking changes. Oops. Let's see.
That's your zone.
So the next thing I wanted to show is the pip file, the pip file.lock. So pip will use a pip file as a manifest and then a pip file.lock as a lock file. The lock file is basically taking the pip file and it's including a lot more metadata. So it includes the SHA-256 hash, which enables insurance, and then not insurance, but assurance. And it also includes any transitive dependencies. So with just a pip file, you can usually generate the entirety of the build like anything required for build reproducibility. It's the most detailed document as far as software dependencies go. And you can see it can get pretty lengthy, especially I don't know, this is a pretty small project, but larger projects that can be significantly long. And I just like to show off pipenv graph, which actually creates a dependency tree for these. So you can see the direct dependencies, and then the transitive, and then their transitive. And if this was a larger project, the whole screen would just be full of software dependencies. Cool. So why does all this stuff matter? I've been talking, there's a lot of open source code used by all the projects in the world. There's a lot of software packages being imported into your project and your environment, but why does that matter? Well, in 2023 alone, there were over 28,000 CVEs. And if you go to the GitHub Security Advisory database, there's over 215,000 total advisories. That being said, roughly only 16,000 GitHub Security Advisories are reviewed and approved by the GitHub Security Advisory team. So if you're talking just the open source space, as per GitHub, technically there's only 16,000 reviewed advisories, which is pretty small when you consider in 2022, I believe it was, there were over 52 million new open source projects in just a single year. So 16,000 advisories, 52 million projects. Yeah, not many, not many when you talk about scale. Um, Speaking of CVEs, 28,000 seems like a lot, but in the software supply chain security space, when we're talking about open source projects, most CVEs are actually targeting. Well, I wouldn't say most, but a lot of CVEs are targeting commercial or internal projects, IoT devices, things that are totally irrelevant to the software supply chain security space. So I would actually say there's a pretty severe problem as far as a lack of vulnerability discovery and disclosure when it comes to open source software packages. Uh, Taking a closer look at those 16,000 reviewed and approved advisories by GitHub, you can see an ecosystem like Java, JavaScript, pretty decent. 4,500 vulnerabilities, almost 3,300 for npm. I mean, that still seems pretty small, but when you talk about something like Swift or Elixir and Dart and Flutter, which these are all programming languages, um, you know, at Semgrep, we have customers who ask us to support Dart and Flutter for supply chain security. Well, there's only 8 known vulnerabilities. like you're going to pay us to make sure that you're not using one of these 8 vulnerabilities, and these 8 vulnerabilities impact I think 6 different projects and that's 6 projects with specific versions. Now, what are the odds of using one of those 6? Pretty slim, and I definitely wouldn't pay for it. Same thing with Swift. Swift has 33 known vulnerabilities in the open source space, and they actually don't have many open source packages. I think it's around 7,000 available software packages in the Swift store. I forget what they call it now, Swift Package Manager, something like that. And then you look at something like Rust, where there's 400,000 packages, and I believe around 300 projects with a known vulnerability. So again, at scale, like we are not doing a very good job of discovering and disclosing vulnerabilities in the open source space. But there's not really a whole lot of incentive. There used to be hunter.dev, which would pay out for disclosing open source vulnerabilities, and then they would also pay you to create a pull request for a fix. They no longer, so hunter.dev was acquired, and now it's hunter.com, and they still support that, but only for AI and machine learning projects. That being said, I just recently learned that HackerOne does have like an open source. I don't know what they call it, but they do incentivize researchers to disclose open source vulnerabilities to some extent. Similarly, I think GitHub has something like that. So if you're interested,
Hey, Circles.
yeah.
Sorry to interrupt. I actually have a question for you if you don't mind.
Yeah, go for
Yeah,
it.
so as far as like the open source, like I've had a lot of people just be like, "Oh, well, open source is great because it's more secure." But based on what you're saying, it doesn't necessarily seem that way because there's an issue with just the open source community. They're not getting paid for what they're doing essentially, and at the end of the day, you're doing like quite a bit of work to do that. Would you say that's like accurate, or I was just curious on your thoughts on that?
Yeah, I don't know if you saw my LinkedIn, but I think I posted like something almost exactly that like 2 days ago. It's just like, everybody talks about open source being more secure. I don't know if I believe that anymore. But I guess the fact of the matter is, like, the very well maintained projects in the open source community, talking about like curl, Python, like the entirety of Python open source, or Linux distros, stuff like that, they do have quite a bit of backing, and both financially and from like a technical skills perspective, and those I would probably say are more secure. But when we're talking about GitHub at scale and their 52 million new projects per year, where most of them are published within a day and never touched again, yeah, those ones are probably not nearly as secure. What's really been interesting to me lately is all the AI machine learning dependencies, because like this is a mad dash. Like everybody's racing to just be an innovator when it comes to artificial intelligence, and there are many pathetic vulnerabilities popping up, like just in Python, like seemed like just passing unsanitized input to exec statements with shell enabled and stuff like that. Like it's getting pretty gross.
Yeah, I
Um,
just actually found your LinkedIn before the call. I'll for sure check that out. Thank you.
yeah, for sure. So that's actually it brings up an interesting topic, which is a lot of my research is on software package vulnerabilities. But what I'm also spending a lot of time with lately is what we're calling dependency health. And so dependency health is using heuristics to determine the likelihood of a package being well maintained. So was the last commit 10 years ago? Okay, probably not a very good package to be using. Software security just wasn't the same 10 years ago. I think we can all agree on that. Is there only one maintainer? That's kind of a lot of responsibility for one person. Uh, yeah, so things like that can attribute to having like a risk acceptance or uh, performing a risk assessment on whether or not a software dependency is suitable or not. And so uh, there are tons of software vulnerabilities. I know I've been talking about how we're not doing good enough, but if you're like a massive company, like a Fortune 500, a big bank, Disney, Google, whatever it might be, you will probably have hundreds of thousands of software supply chain vulnerabilities if you are to run something like Semgrep or Dependabot or any of these alternatives. And so what we've created is what we call reachability analysis. And it's basically a two-step process. We take a look at your lock file. We determine what software dependencies are used by your project. And then we use the Semgrep open source static code analysis tool, or the Semgrep open source engine. And we actually make sure that you're using the vulnerable function for the security advisory. So a lot of times a security advisory will say there's a known vulnerability when using this function of the package. Well, pretty much all the other solutions out there in the software supply chain security space simply say, hey, you're using a dependency with a known vulnerability. They don't actually care whether or not you're using the vulnerable function or not. And so that's something that we do to prioritize vulnerabilities. And actually, what has kind of been proven at this point is that the likelihood is that you're only using 10% of any given software dependency, which means you only have a 10% likelihood of using the vulnerable function, or roughly a 10%. And a lot of our testing, we've narrowed down to just 2% of findings to be reachable. And so I could kind of walk through that process on what we do on the supply chain security research team. Let me just change how I'm sharing my screen. All right, are you guys able to see the GitHub page?
Yep.
Yep.
Cool. All right, so what we do on the security research team or the supply chain security research team, basically every new GitHub security advisory that's either high or critical severity, we go to the GitHub security advisory page, we review it, we say, hey, this is the package pillow, and it's saying the pillow.imagemath.eval function in pillow before version 9 allows the evaluation of arbitrary expressions. Okay, so pretty obvious vulnerability here. It's going to be it's going to use eval, which is going to exec pretty much anything you pass to it. So if any unsanitized user input was being passed to this function, it would be a very bad day. So to put it into perspective, well, the next thing we do is get an understanding of what the software package does as a whole, but I'll skip that step for the most part. But to give you a perspective on how effective reachability is, we can just do, let's search GitHub for import pillow. And so we're talking 132,000 files that are importing pillow. And there's other ways to import this, so that's not going to be all of them. But let's even 100,000 or more is a good excuse to start using reachability. Now we know the vulnerable function is image.eval, specifically pill.image.eval. So if we search for this, we're down to 246 files. And again, this isn't going to be all of them, but it's also seems to have a lot of false positives. If we go to just Python, now we're down to 23 files. So we went from 100,000 plus to 23. If this were to be reachability or Semgrep's reachability. So the next step is for our researchers to go into the Semgrep playground, which is publicly accessible. You can just go to semgrep.dev and play around in here. I think I wrote my first rule actually during my interview with Semgrep. It took like 15 minutes to get a somewhat of an understanding of the syntax. It's definitely the easiest static code analysis custom rule writing I've ever experienced by far. But so basically, we have this is a pretty complicated way of doing it, but I have a regex to look for PIL. So this is just going to simply search to see if PIL is matched. And then I have an import statement. So it's saying, firstly, find import PIL. And then these three dots say everything else after it. So I'm looking for import PIL, and then I want to match everything else. If I highlight that part out and I run it, you can see it does exactly that. But what's interesting here is I did not write import PIL. This says from PIL. But that's kind of, so Semgrep stands for semantic grep. Grep is just, regular expression searching. Semantic grep is smart enough to say, hey, import PIL is the equivalent of from PIL. And we do this for, I don't even know how many languages at this point, but this is kind of like the magic within the Semgrep engine, is that you can write a very simple rule like import PIL, and it can still match alternative but equivalent ways of writing that in code. So similarly, I have pattern pil.imagemath.eval. And if I run it, it'll match imagemath.eval. Again, I don't have PIL dot, but it knows that it's equivalent because it's importing. It's because it's using the from PIL up here. Now, I said this rule is overly complicated because really I could just do this and it exactly the same. So I guess when I wrote that, I probably had too much to drink. But so yeah, that's how simple it is. If you wanted to run Semgrep to find this function used, say you had 100 packages or 100 projects in your organization, and you wanted to know everywhere that you're using a specific function, it literally would take you, 10 seconds to write this rule, and then it would probably take just a couple minutes to run it against all your projects. Semgrep is crazy fast. I don't remember the numbers off the top of my head, but it continues to blow my mind. There's also turbo mode in the playground, which is a fun little feature to play with. So this actually will make matches in real time. So if I do like block size, I can do that. And I don't know if it's in the open source version, but we also have like autofix where you can say, hey, replace block size with some other name. And then we have open source rules that the community contributes to. So actually, a lot of our competitors, funnily enough, actually use Semgrep open source for their static code analysis. So we've kind of created competitors in a sense, but we have pro rules for our commercial platform, which is where we try to provide a unique value, but also supply chain security and our software composition analysis tool for supply chain security is commercial only, but I guess I shouldn't really say that. The interesting thing that I promote all the time, and I kind of continue to question why I'm allowed to do this, but Semgrep, the entirety of it, like all three of our products, is entirely free for everybody to use infinitely for up to 10 unique contributors. But that excludes open source projects. So if you wanted to do like open source vulnerability research, you can literally just go clone, and I've actually done this. You could go clone like 100 open source projects and run Semgrep against it. And so and you get a dashboard like this. I can go to my projects. You can see I was testing against PyTorch and PostHog, TensorFlow. But focusing on supply chain security, I could show you that reachability component. And so, well, another thing, this is more ranting, to be honest, but in supply chain security space, mediums and lows are absolute garbage. They hand out criticals and highs like absolute candy. I mean, 90%, I wouldn't say 90%, but a very large percentage of even the criticals and highs are uh, denial of service vulnerabilities and like all this BS that is never going to be a concern whatsoever. So I always just trigger these two. I just deselect both of these. And then transitive vulnerabilities, as I've been talking about a ton, you can't do anything about a transitive vulnerability. You unless you're gonna go as far down the chain and you patch it yourself and then go up the chain and patch it at every single level, you're never gonna remediate a transitive vulnerability. So all it's really good for is to say, hey, I'm using a direct dependency that has a lot of transitive vulnerabilities. Maybe I shouldn't use it. Um, so I also just knock these off. So now we're down to 8 vulnerabilities that we can effectively and probably should definitely remediate versus the starting number, which I believe was like almost 90.
Hey, Circles. I actually got another question here, Sponger,
Yeah, what's up?
if you don't mind. Eh, so is have you ever had because I've had third party pen tests done on like applications in my some of my previous companies, and like the critical and highs are definitely issues, but then we got down to some like the medium and lows, and if you actually started chaining them together, or hey, if you combine like a bad password or something like that with that medium or low, I mean, this is application security different from this, but essentially an attacker could chain together those medium and lows and essentially get like a higher critical. Have you seen much of that at all, or is it just essentially, hey, focus on critical and high because of risk, reduce it, and if you have time, like look at the medium and lows?
So yes, from a pen testing perspective, definitely agree with you. Um, in the supply chain security space, I personally haven't seen any interestingly chained attacks. That might
Okay,
just be because there's so many damn highs and criticals that malicious actors aren't going that deep yet.
that deep, yeah,
Um, but yeah, like I said, it seems like the supply chain vulnerabilities. So the CVE submissions or GitHub Security Advisory submissions, I guess they're strongly taking into account that it is a software dependency, which might be inflating the severity. Because I see very pathetic like regex denial of service vulnerabilities that are just given a critical, like without question. Um, so that's why I just tend to ignore the mediums and lows. But
yeah. And yeah, just to be clear, like I don't have much experience in the supply chain security, which is why I asked. But so it's like, yeah, thanks for clarifying.
yeah, for sure. What's the other thing I was thinking? Oh, so the other thing to say, like even these criticals and highs, if you were to be doing a pen test, likelihood is that they wouldn't warrant a critical or a high vulnerability, from a manual testing perspective, because the CVSS scoring is, like I mentioned, does take into consideration like the scale of the vulnerability or the how widely used it is. Is it likely to be used by a public application? Well, maybe in some instances it's used on a public instance, but for the consumer's case, it's an internal application, so the risk is going to be reduced. Um, but as far as code scanning reachability goes, what's pretty cool is it tells you exactly where in the code is the vulnerability being used. So you can just click on the link and it directs you right to the code and where you're using it. You can also integrate this into your CI/CD. So every time a developer creates a pull request, it can run Semgrep on the diff, and it can highlight vulnerabilities for you and make PR comments and suggestive fixes. We're playing around with a an assistant AI bot, which is I think we have a pretty unique approach where instead of it helping to identify vulnerabilities, it's kind of like a checks and balances thing. At least that's how I look at it. So a lot of times the AI will be like, no, Semgrep is flagging this, but it's a false positive. You should probably ignore this, which I think is pretty cool. Because unfortunately, static code analysis just can't be 100% accurate no matter how much we try, but that is definitely our priority is to keep noise down. Cool. Well, that took a little longer than expected, but we can get into some rants. Anybody have any particular questions before I start complaining about everything?
So, really quick, you had mentioned earlier in the talk about how you don't generally include transitive dependencies within manifest files and such anymore. I was curious why that might be. Like, does that is it potentially because it like elevates it to direct dependency or something like that? Like, why is that?
So the lock file will have the transitives. So what we do is we at Semgrep we will take the lock file, we'll list out all of the dependencies that were parsed from the lock file, and then we'll cross-reference that with the manifest. And if it's in the manifest, we know it's a direct transit a direct dependency. If it's not
Ah,
in the manifest, then it's a transitive. We should probably be doing that a little better because it's not necessarily accurate all the time. Because as the example I showed, the the manifest included transitives. So that's where things get tricky. Is like trying to handle current practices versus best practices 10 years ago. But,
I see. Thanks.
yeah, for sure.
Hey, Circle. Great presentation so far. I really appreciate it and your time on this. So I interact with students at a university, and if I were to mention this Semgrep, uh, how would you go about recommending one of them goes and like finds a wiki or some place to really get up and going and trying this out? Is there something you can provide really fast here?
I probably should have a better answer for that. I mean, so the open source GitHub page is pretty well detailed. We do have pretty awesome documentation, actually, now that I'm
Ooh,
starting to remember. So yeah, at semgrep.dev, we have documentation that goes as deep as if you want to be contributing as a developer, if you want to be using open source Semgrep, if you want to use the platform. Um, the only thing I will say is Windows support is a little funky right now, where
hmm.
I I'm probably one of like 3 Windows users at the whole company. But actually now I have like 3 MacBooks, so I do all my emails and stuff on Windows still because I just can't give it up.
Sure. Okay, yeah, I'll take a look at this quick start page and provide that information. Great, thanks.
Yeah, if you want to shoot me a message on Discord, we recently brought in Tanya from We Hack Purple, who's helping a ton. She's a pretty big name in the industry, who's helping a lot with like training material and just public content to educate people on AppSec and and how to use SemGrep effectively. And I can double check with her to see if we've made any progress on like basically a course. I can send it over to you if we do have something.
Wow, that'd be amazing. Awesome. Thanks, Circle.
Yeah, of course. Cool. Well, have any of you heard of S bombs and how it's going to save the planet from a software supply chain security perspective?
That's what I'm
I've heard,
told.
I've heard about them, but that they're really difficult in practice, but not much about it otherwise.
Yes, they are very simple in practice, very difficult to do accurately, successfully, and actually contribute any value. So, uh, the one thing I do appreciate about it is that it's kind of like a gateway drug. It's gotten it's generated a lot of buzz for software supply chain security. Most people probably would have never heard of it. Every time I go to a bar or something and I mention it, they're like, "Oh, that you mean the SBOM stuff?" I'm like, "Oh, damn it." But yeah, so an SBOM is a software bill of materials. Basically, as I've been talking about discovering what software dependencies a project uses, that's all an SBOM is. It's intended to be a bill of the materials for your project. So what software dependencies are required for this project to operate. Now, the reason why I have a hard time with it is because it isn't actually a security tool at all, and like at least in its current state. It's like saying that an asset inventory is a security tool. It it's an asset inventory is definitely something that you should have, but it's not going to point out vulnerabilities. It's not going to effectively prioritize them. It's not going to effectively help you remediate them. All it's going to do is tell you that you have assets. Um, so SBOMs, it's actually a big question right now. Should SBOMs even list what vulnerabilities are known with these dependencies? Because security advisories are published every hour, whereas an SBOM is likely to have been generated, a month ago or 2 months ago. And then we also have instances like cloud services where there's changes being made every minute, every hour. So are you going to generate a new SBOM, every 15 minutes and then distribute it to all your vendors every 15 minutes? And how are they going to ingest those and effectively be able to calculate risks of using your product or application? And then what happens if the risk exceeds a certain level? Are they just going to like turn it off? There's so we're going to get into a very interesting time, because the government definitely is not letting their foot off the pedal as far as promoting SBOMs. But we have a long way to go before they're effective from a security perspective. Apparently,
I get a
myself.
question for you, Circles. Do you have
Sure.
another one? I mean, I have lots of questions as usual, but do you have an example of an SBOM? I could probably go look one up, but I'm used to seeing SBOM from, and it gives me nightmares back in college of like SAP, where you're looking at like the raw materials list, and it's just like an insane list and just extremely difficult to look through. So
Yeah.
I haven't seen one based on what you're describing. I did read your article the other day about SBOMs, and it was pretty interesting.
So this is still in beta, but we are creating SBOMs in the Semgrep application. And so what do we support? Yes, Cyclone DX 1.4 currently, JSON or XML. We do include the known vulnerabilities, and we also in the metadata mention if they're reachable or not. So that's kind of similar to Vex. Vex is like the thing that's supposed to associate vulnerabilities with SBOMs, but they're kind of two totally different things that Cyclone DX has tried to put together. But to your point, yeah, today it's still just like a pretty grossly formed JSON, that a human trying to. I've seen people on LinkedIn try to tell me that they manually review these things and find flaws and issues in them, and I just kind of don't believe them, or maybe they haven't looked at enough of them, because you will find a flaw in every SBOM you look at. If you take, somebody's actually done this. There's I think he's like a distinguished researcher at ChainGuard or something like that, or head of research at ChainGuard. He has a paper talking about, I think I actually mentioned it in here. Yes, this one, a viewpoint on knowing software build materials quality when you see it. So they actually compared the results of SBOM generation tools, and just like it's glaringly obvious that you can take 3 tools, generate an SBOM for the same project, and get very different results. So that's where the industry is currently at.
Yeah, I feel like I've heard more and more about SBOMs, and it's been only coming up, I want to say, in the last month or so. Or I've had clients like, "Oh yeah, is it like an SBOM with some specific tools that we were looking at?" Um, but yeah, it's interesting.
I've had clients. Well, I've been asking out of curiosity, but I've asked clients if they are requesting SBOMs as part of like vendor due diligence, and some at least 3 have said yes. And I ask what they do with them, and they say nothing. It's just like,
Classic.
okay,
Check the box.
yes. So yeah, so I guess the 3 main rants I have are around SBOMs, transitive vulnerabilities, and vulnerability disclosures slash transitive dependencies. Because I know we're maybe a little over, but last thing to mention is a transitive vulnerability is so that's a vulnerability of a dependency's dependency. Now, if you're using well-maintained software dependencies, reputable maintainers, and they're knowingly using a vulnerable dependency, they're likely going to generate a security advisory for their project, which now makes it a direct vulnerability, which removes the entire need for a transitive vulnerability. Now all it's doing is duplicating work or duplicating issues if you're using something like Semgrep for supply chain security. So the industry doesn't have any standard practice around how you should be reporting transitive vulnerabilities. The CNA procedures, which is the CVE review process that everybody's supposed to be following, there's two rules. One says that you definitely should not be, and then the other one is very contradictory, and my interpretation basically says you definitely should be. So I have a really hard time with it. I participate in the OpenSSF vulnerability disclosure group, and I complain about this every week, and everybody, yeah, we're all just kind of in agreement that it's a mess. If any of you are involved more so on like container security or things of that nature, a lot of these similar issues are identical in the container Docker space.
Yeah, I was gonna say, like image scanning and specifically like package scanning, and understanding all the different layers in a container image and things like that. Like you have your base image, which could be like Ubuntu, but then you have all the packages and add on. This is what it kind of like reminded me of as far as like the supply chain.
Yep, exactly. And the attacks are even the same. So in my newsletter getting published tomorrow for Cram Hacks, I'm talking about a dependency confusion attack for containers. Well, it's a blog post about dependency confusion, but specifically for Docker containers, basically saying like if you in your config files, when you're specifying a mirror, if you put the remote destination first before your local for and then you happen to try to download a mirror and somebody has published an image with the same name, you could very easily just be installing malware instead of the Docker image that you were intending to.
When does that drop tomorrow? Because I have a lot of clients that leverage Kubernetes, and that's like one of the spaces I have been working in.
Yeah, so I publish a weekly newsletter every Wednesday at 7:24 a.m.
Sweet.
And it's just about software supply chain security, both software, containers, CI/CD. So that I guess that's my last and final rant I'll leave you guys with is software supply chain security is freaking everything. It is so ridiculous that nobody can give me a good definition of what this space even is, and it's my entire job. I commonly tell people that coffee is the biggest software supply chain security concern. I actually worked at a company while I was in my undergrad where the government gave us millions of dollars to research the effects of sleep or lack of sleep on software vulnerabilities, like how many more vulnerabilities were introduced when developers didn't get sufficient sleep. It's like, I guess that's kind of software supply chain. Like if the devs aren't getting their caffeine and sleep, we're going to have issues. Oh, and surprise, surprise, it costs millions of dollars to learn that, yes, if you don't sleep properly, you're likely to make more mistakes. But I probably could have told you that without the study.
Wow. Nice.
Cool. Well, that's all I got for you guys. If nobody has any more questions.
Anyone else have any other questions for Kyle?
Yeah, can you throw up your information real quick back to your LinkedIn and stuff like that so I can check that out? That'd be awesome. Thanks.
Sure, my information. Oh, not no bad. Yes.
There you go.
No, I'm just kidding.
Perfect.
Link. Let's see. Yeah, so there's my LinkedIn and then cramhacks.com. Make sure you put an S, cramhacks.com, My undergrad blog was cramhack.com without an S. That is now a porn site, so don't go there.
Oh, jeez.
Oh,
Yeah, I
Could
I
make
thought
some
I
money on
subscribed
that.
to the wrong newsletter.
Yeah, that's where all my clicks are going. It's pretty disappointing.
Well, it was kind of security porn, but it was good.
Yeah, thanks, Kyle. Appreciate you doing the talk and everybody coming out tonight. Anybody else have any other questions for Kyle? Or want to know more about supply chain security in the future? I'd like to get some more information about Semgrep and maybe like I don't know, like a demo on how to make the like rules and stuff like that. That'd be kind of cool.
Yeah, I could see if anybody on the security research team would be interested. They so I handle basically everything supply chain related. Now we're starting to dabble with the secrets product a little bit, helping writing rules. And so our secrets product also does validations. So it's not just saying, hey, you have secret exposed. It's actually testing to make sure the secret is functioning. Very similar to Trufflehog, if you're
Oh,
familiar
okay.
with them.
Yeah, that's what I use personally.
Nice. And then our security research team are just like pretty much exclusively writing very focused SaaS rules. So like, especially our bigger enterprise customers, they say, hey, you know, we're doing a lot with JWT, and then our guys just deep dive on JWT. What are some classic vulnerabilities? How can we write super fine-tuned SaaS rules for those?
Is Semgrep's only used for like like source code, right?
Yeah, so strictly static code analysis currently.
Okay. Okay.
My favorite part about it is the code doesn't necessarily need to run. So we've had independent consultants compare us to other products, and like a lot of the feedback is just Semgrep is phenomenal just for the sole purpose that like we don't have to tune the freaking thing on every project we run we want to scan. I used to use Veracode a ton in the consulting space, and it was just always such a headache. You got to create your binary with certain flags. You got to tune the static code analysis tool with like different policies. It was always just such a big headache. Semgrep, you cd into the directory and you just type semgrep scan or semgrep ci, and magic happens.
What is that? What is the biggest difference between the open source version versus the paid version?
So the open source version lacks interfile analysis and taint flow analysis. So, for example, if you are using sanitizers, maybe like for SQL, the open source engine is less capable of saying like, yep, there's a sanitizer before being passed to the potential SQL injection vulnerability. Or the pro version has a better understanding saying like, oh no, that user input is being passed to a potential SQL injection, but there's a sanitizer in the middle, and so it's a false positive. And then interfile analysis enables us to basically do semgrep from file to file. So like if there's a function declared in one file, we can still see it in the other.
Okay. Yeah, it's important.
Yeah, and then the pro rules is probably like our biggest differentiator because the community rules are great. Actually, Trail of Bits is a big advocate for Semgrep. They have a whole guide on how to use Semgrep, and like tips and tricks on what they use for their engagements. They also publish most of their rules to the community. So
Oh
but
yeah, I'm a big fan of their stuff.
yeah, it's just there's a big difference between like internal SAST and consulting SAST, I would say. Like consulting SAST, you're more willing to take some false positives because that's your job, is to, you know, review them, make sure they're valid. Whereas on the internal side, if you have thousands of projects, you may really only just want to see the ones that you're 100% sure are vulnerabilities. So our pro rules are more tailored towards internal use, whereas the community rules will maybe broader coverage, but more false positives, of course.
Cool. Alright, well, if we don't have anything else, we can call it. Anybody want to bring up anything else last minute?
So aside from coffee, what do you drink? Just in case we had to
Um,
buy you a drink if we like met you at a con or something.
well, I am in San Diego for you guys that are local, so probably I would definitely be at B-side San Diego. Typically go for like a stout. I love a stout. Big Guinness guy. Actually, just for Christmas, I got a bunch of Guinness chocolate, which were friggin' delicious. But tonight I had a pear whiskey, which was I don't remember what it's called, but it's pretty delicious.
Have you
Nice.
gone
Nice.
to the DC 858 meetup groups, Kyle? I don't think I've seen
Um,
you there.
I have not been to any local meetups besides the quarterly mixers and
Okay.
the actual B-sides events. But I just finished my master's in December, so I have a good bit more time now, and I'm hoping
Nice.
to start hanging out with a couple of the groups.
Nice. Yeah, that's awesome. I'll actually be at B-sides as well.
Nice.
Possibly doing a talk on container security, so it'll
Oh,
be right
dope.
up your alley.
Yeah, for sure.
Cool. Well, thanks again, Kyle. We can call it a night. Feel free to hang out, guys. Stick around. But I'll end the recording, and I got to sign off.